Hello, everybody. I have here in front of me the 2023 Specialist Mathematics Exam 2, and I intend to show you the solutions for it. A little bit of forewarning here. I use the Casio ClassPad, not the TI Inspire, so the solutions for this exam will be done in the Casio ClassPad, not the TI Inspire. I'm pretty sure, in fact, I'm 100% sure that there's a video out there showing you how to complete this exam with the TI Inspire. It's a good video, but a lot of it is done with pre-programmed programs, which is not very helpful if you want the solutions and how to do a problem. Anyways, this is the Casio ClassPad. If you know it, this is the video for you. If you don't know it, you can still follow along, so it's no biggie. So viewed from above, scenic walking, who cares about that? So all we care about is the piecewise functions over here, and that they meet at 1, 0. So we're supposed to show that a is equal to -1 and b is equal to 0. So in order to show that, we need to show that these two functions are equal to each other at x equals 1. So we can write at x equals 1, x plus a squared is equal to e to the x minus 1 minus x plus b. And we know that's going to equal 0 because they've specified at x equals 1, y equals 0. So we can expand and substitute basically, 1 plus that, and then e to the 1 minus 1 minus 1 plus b equals 0. So that implies that b is equal to 0 because this whole term here is equal to 0. This term here is equal to 0. And then all that leaves us is 1 plus a is equal to 0 via the null factor law. And so a is equal to -1. So we can highlight these in a beautiful pink. Look at that. That's just beautiful. I'm sure that gives you a moment of happiness in the enduring suffering you get during exams. So B, we need to verify that the two curves meet smoothly at point C. So what does the word smoothly mean? Well, what smoothly means in the VCAR sense, what they mean is that at the point that they meet, their derivatives are also equal. So d dx of -x, x minus 1, now that we know what a is equal to and verified it, it should be equal to. So let's find out what this is equal to. This is equal to, let's whip out the old Casio ClassPad and let's derive this, differentiate, I suppose, and then sub in x equals 1. And let's just make a note that that's what we're doing. And then we can say that this is equal to 0, but this is also equal to the derivative of x minus 1 minus x at x equals 1. And then you can say that, therefore, the two curves, blah, 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 meet smoothly at point C. Happy days. Yeah, nothing to really highlight there. So we need to find the coordinates of point A. So point A looks like it is the turning point of the first equation. So it's the turning point of this equation. So the turning point of -x, x minus 1 squared. We had already calculated the derivative. So let's just set that equal to 0 and solve that for x. We get two answers, x equals 1 and x equals a third. Well, x equals 1 is right here, and that's at point C. So that's clearly not point A. So we know point A is going to have an x value of a third. So that's the first part of our coordinate. Let's drag this down here and substitute in x equals a third, and we get -4 on 27. So that's our answer. Pink. I don't really like that. It doesn't go over everything. So we need to find the coordinates of point B. This looks like it's a point of inflection of the first curve, so we'll write that. Point of inflection of negative x, x minus 1 squared. So that's just going to be the derivative of the derivative. So let's derive this once more. That's implicit differentiation. We don't want that. Derive that and set it equal to 0, and we get an x value of 2/3. And then let's sub in 2/3, which we can do easily. And we get negative 2 on 27. That's our answer. The return track from point D to point O follows an elliptical path. Find the Cartesian equation. Okay, so basically the plan of attack when trying to do these parametric equations when you're given trigonometric functions is turn everything in terms of the trigonometric functions. So cosine of t is equal to x minus 2 on 2, and sine of t is equal to y on e minus 2. And then employ Pythagoras' identity of cosine squared t plus sine squared of t is equal to 1, and you get x minus t squared on 4 plus y squared on e minus 2 squared is equal to 1. Happy days. And now we need to sketch it. Okay, so it's going from D to O. So meaning this is at t is equal to pi on 2, and this is at t is equal to pi. So it's just gonna go like that, probably. You could, in fact, you probably should, in order to get full marks, is find a point in between the two values, like pi on 4, and you'd probably get something that goes... Oh, dearie me, it's brought me all the way back to the top. One note, more like disruptive note. Ignore me. And then you're more likely to get something like this, probably, with the point at 1 going to be a bit higher than 0.5, I think. Okay, now we need to write down a definite integral in terms of t that gives the length of the elliptical path. So that's going to be the parametric equation of the arc length of parametric equations, and that's just on the formula sheet. And so that's the square root of dx dt, which is negative 2 sine of t, quantity squared, plus dy dt, which is e minus 2 cosine of t squared. Draw a big line, all with respect to t, and that's our answer there. And now we need to evaluate it, which is a bunch of button pushing, which is nothing we can't do. And then the square root of, let's see how fast we can type this without making any mistakes. First mistake. Make sure your e is actually Euler's number, not just a random variable. And this is the answer we get. We get 2.255 kilometers. That's correct to 3 decimal places. Onwards and upwards. Let's take a drink. All right, now we need to verify that w is a root of this. So w 7th minus 1 is equal to cis of 2 pi minus 1, which is equal to 1 minus 1, which is equal to 0. So we just employed de Moivre's theorem in that 7th thing, w, is timesing this by 7, and that gets us cis of 2 pi. All right, now we need to list the other 6 roots of blah. So let's just do that in the Casio ClassPad. And let's solve that. And then we get all of this nonsense. All right, the first thing that jumps up to me is let's call Z1 equal to 1. So that's our first real root. Then let's just go right to left. All right. The key thing to notice here is that cis is cosine plus I sine, but here we have a minus. So that's going to flip our angle in the cis thing. So we get cis of negative 2 pi on 7 since we're doing the principal argument. And that's just a reflection of this, which is cute because that's how roots of unity work. So we're going to do the same thing here, noticing that it is a minus I sine. So we get that. Z4 is going to be the next one, which is cis of negative 6 pi on 7. And then the rest are just reflections of those. They're going to be positive angles. And Z6 is going to be cis of 6 pi on 7. I hope that is legible. So now we need to plot and label them. So this is going to be Z1. Well, here it says do it in polar form. So what is 1 in polar form? Well, that's just cis of 0. And so kindly, they've separated all of these circles out into sevenths, pi sevenths. So our first one is going to be here, which is W. And next one is going to be here, which is 4 pi on 7, which we've called Z5. This one's going to be here, Z6. And then we've got negative 2 pi on 7, which is Z2 we've called. And then that's going to be Z3. And this is going to be Z4. Just making sure we've got 1, 2, 3, 4, 5, 6, 7. Happy days. On the Argand diagram below, sketch the ray that originates at the real root of blah and passes through the point represented by that. Okay, so the real root is here, and so it's going to originate there. And if it originates, we're going to have an open circle. And then the point represented by here, so that's the point there, which is W. And let's get a different color here. Give me a straight line, please. And so that's going to be our ray. Find the equation of this ray. Okay, so we want to find this. So this is theta. So let's find what we know. Let's do a nice orange here. So we know that this angle here, because this is given in polar form, is 2 pi on 7. And since this is a unit circle, both of these side lengths are 1, meaning that this is an isosceles triangle, or whatever the word is, meaning that these two angles must be the same. And so the sum of all the interior angles must add up to 1, which means that these two angles are going to be the half of this difference here. So it's going to be 5 pi on 14, meaning this is 5 pi on 14, which means that this is 9 pi on 14. So we end up getting the argument of z minus 1, because it originates at z equals 1, is equal to 9 pi on 14. Happy days. 1 mark. Lots of 1 mark questions. Oh, here we go. Look at that. Another 1 mark question. So we'll verify that this can be expressed in the form. Okay, so let's verify so we can use the information given in the question. Since I don't want to write all of that, we're just going to do that. And then we need to phrase this in the form of this. So I'm going to expand. So we get z7th minus z6th plus z6th minus z5th plus z5th. You can sort of see the pattern here. So we're just going to do a dot dot. And minus z plus z minus 1 is equal to 0. And that's going to cancel all of that, because this and this cancels, this and this cancels. So everything in the end is going to cancel except the first and last terms. In essence, you could think of that as telescoping series, which you might have learned as part of proof by induction or something like that. No, sums. But yeah, that's what that is. Express cis of 2 pi on 7. Let's just see if I've got cis defined. Okay, so we do have cis defined on the calculator, which if you don't, just define cis of x equals to cosine of x plus I sine of x, and it makes everything so much easier. Let's clear, because we're done with the majority of the other questions. So cis of 2 pi on 7 plus cis of 12 pi on 7 is equal to 2 cosine 2 pi on 7. Look at that. Fun. Given that W equals satisfies this equation, so it's a solution. So we're going to say that Z is equal to cis of 2 pi on 7 is a solution. So if we plug it in, it should equal 0. And so now we need to use that in order to show that this is true. So let's do that. So cis of 2 pi on 7 minus 1. And then if we expand the first one out, we get 12 pi on 7 using de Moivre. Then we get cis of 10 pi on 7. And then since this is a pattern that just repeats, I'm going to do this until we get cis of 2 pi on 7 plus 1 equals 0. Via the null factor law, we have cis of 12 pi on 7 plus cis of 10 pi on 7 plus blah 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 plus cis of 2 pi on 7 plus 1 is equal to 0. All right, so what can we do now? What can we simplify this to? Well, we knew that cis of 2 pi on 7 plus cis of 12 pi on 7 is equal to 2 times cosine of 2 pi on 7. So let's see if that's a pattern that repeats. So let's try 4 pi on 7 plus 10 pi on 7. And that is a pattern that repeats. Let's try 6 pi on 7 and 8 pi on 7. And that's, okay, so perfect. So we're just going to have up here, so 2 cosine of 2 pi on 7, and that's from 12 pi on 7 and 2 pi on 7, plus 2 cosine of 4 pi on 7, and that's from 10 pi on 7 and 4 pi on 7, plus 2 cosine of 6 pi on 7, and that's from 6 pi on 7 and 8 pi on 7, plus 1 is equal to 0. And so then if we expand that out, or not expand, minus and then divide by 2, and we get something that's nice and happy, which was required. So as required. Hopefully that makes sense. Skipped a couple of steps, which you probably shouldn't do in a show that, but that's all the working out space we were given. Okay, question 3. So we're going to clear all our variables. We're going to clear all, and we're going to get the slammer off complex, because no more complex. This is not a complex question. The curve given by y squared, so it's in the form y squared, is rotated around the x-axis from 2 to 5. So the volume, we're just going to employ the formula from 2 to 5. Well, they've already put it in the form y squared, so we just substitute that in dx. And so now we need to calculate the value of this. So we're going to do pi times the integral from 2 to 5 of x minus 1 dx, and we get 15 pi on 2. Express the curved surface area of the solid in the form pi times the integral from... Okay, so let's employ the surface area formula. So we get 2 pi. So it's from 2 to 5. So that's the easy part. And then so we need a solution for y. So y, one of the solutions is this. And so we're going to use that. X minus 1. And we need to times it by 1 plus dy dx squared. And so we'll calculate that later. So let's do that now. We get square root of x minus 1 times by the square root of 1 plus something squared. So we want the derivative of x minus 1, square root of x minus 1. And we want that squared, and we get that. Okay, so the first thing I notice is that we can pull out a half from that. So that's where we get the only 1 pi in front. And then this, when you expand them, when you times two surds together, you get to multiply their insides together. And so when you multiply the x minus 1 with the x minus 1, you get the square root of 4x minus 3. And that's the form that they wanted it in. And now they want us to calculate the area. Oops, I didn't mean to bring that up there. Get out. And so let's just use this form and just copy this in, replace the 2 with the 1, we get an answer. And that's 30.846 units squared. I suppose you should also say units cubed, because sometimes they don't give you the mark. Just to explain what I did there, I didn't use this. If you used this, you would get the same answer. It's just this is probably faster. It's all gaming it out. So the total surface area of the solid consists of plus the areas of 2 circular discs. Okay, so what they're really saying is that we have this little vase that we've created. Oh, this is the graph of y, and then this is 2, and then this is 5. So when we rotate it around, we get a little circular disc there, and we get a little circular disc there. So the total surface area is equal to the surface area plus the first disc here. So what's the first disc here? Well, so this point here is 1, and this point here is -1 in terms of this. So we know that the area is equal to pi 1 squared, which is just equal to pi. So plus 1, that's the first one. And then this one, when you plug in x equals 5, you get y equals 2 and y equals -2. And so that's going to be 4 pi. And so that's just the area of a circle. And so that's nice. And then your efficiency ratio, they've defined as your total surface area divided by your volume. So let's put that in. So our total surface area was our surface area plus 5 pi divided by that. And so let's convert that to a decimal. And so that's 1.98. That's the efficiency ratio. So just to make it clear, that's our answer. That's our answer. That's our answer. That's our answer. Nice. Another solid of revolution is formed by rotating the curve y squared equals x minus 1 about the x-axis for x between 2 and k. So it's given that the volume is equal to 24 pi. So we can just employ the formula in order to solve for k. Let's find out what k is equal to. So we're just reversing the formula in order to find one of the terminals of the integral, so what the value of k is. And so let's just do that here. So we k equals -6 and k equals 8. Well, k can't equal -6, so k must equal to 8. So then the total surface area is equal to 2. Let's just employ what we had before, which was 2 to now 8, 4x minus 3. So that's from our surface area equation up here. And that's going to be plus. So if we think of that again, we've got our little y graph here. We've got the same 2 value, and we get, so this is going to be 1, so the area of that one's going to stay the same. So that one's still going to be pi. But this one, well, at x equals 8, we have y is equal to √7 and -√7. Which means that the area is going to equal to pi √7 squared, which is equal to 7 pi. So that's plus 7 pi. Let's get that out of our face so that we can complete the rest of the question. So it's asking for the efficiency ratio of this one now. So the efficiency ratio is going to be equal to total surface area divided by the volume, which is approximately, so let's do this again. So we have the total surface area, which is pi times the integral from 2 to 8 with the square root of 4x minus 3 dx plus pi plus 7 pi divided by the volume, which was 24 pi, as they had told us before. And so we get 1.34. That's that question done. Oops, that wasn't even straight. There we go. All right, next question. We've got differential equations. A fish farmer releases 200 fish into a pond that originally contained no fish. The fish population? All right. So we need to find the values of A and B. So this is basically partial fractions decomposition. So we need to rephrase this. And so that's just turning this into dt over dp. And if we equate that to a over p plus b over 1 minus p on 1,000. So that's over what the question is asking. We can do this by going 1 is equal to a of 1 minus p on 1,000. So that's just equating the numerators. And then if we do that, we realize that since this side of the equation has no p's, that means all of this, the p's must be 0. So 0 is equal to negative, sorry, this should be, yeah, that's fine. 0 should equal to negative a on 1,000 plus b, and 1 should be equal to a. So that's going to imply that a is equal to 1 and b is equal to 1 on 1,000. So that's just partial fractions decomposition. I'm going to rub this off because I don't want examiners seeing my messy working out. And that's the answer you get. You probably could have used a calculator for that and you would have gotten an answer immediately. One form of the solution for p is equal to blah 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 where d is equal. Okay. So the first thing I'm going to notice is that at t equals 0, p is equal to 200. So they've told us in that question that the fish farmer released 200 fish at t equals 0. So we know that 200 is going to be equal to, let's plug it in, 1,000, 1 plus d times e to the negative t, but t is just equal to 0. And so let's solve this for d, and we get d equals 4. So I'm just going to write at t is equal to 0, p is equal to 200, and then d is equal to 4. And that's our answer. The farmer releases a batch of n fish into a second pond, pond 2, which originally contained no fish. So the how much they're going to release is going to be given by when it's equal to t is equal to 0. So q is equal to n, which is equal to, let's substitute it in. So we got 1,000 on 1 plus 9 times e to the negative. That's just going to times by 0 anyways. So let's find out what this is. And so we get 100 fish. Nice. Find the value of q when t equals 6. We can just do the same thing. So we get negative 1.1 times by 6. And we get q is approximately 988 fish. Given that dq over dt is equal to blah blah blah, express d squared q over dt squared. I'm actually not going to do it that way. This is probably going to seem insane, but I'm going to... Okay, I didn't mean to do that. I'm going to derive this twice. That was stupid. We need to do this with respect to t. Hold on, let's try that again. So we get 1,000 on 1 plus 9 times e to the negative 1.1. I'm going to replace t with x just for the sake of my Casio. And that's going to be order 2 because we're doing it twice. Let's simplify that. But it doesn't want it in terms of t, in this instant x, because we'll replace t with x. We want it in terms of q. So we need to replace all the x's, all the t's with q's. Well, what's an equation we've got? We can solve this equals to q. We can solve this for, I forgot the bracket. Solve this for t, and we get this. And we can take this and sub in this. And that looks like a mess, but simplify it and it comes really quickly. So, and that should be a correct answer. On, what's that? How many zeros? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That should be a correct answer. Hence or otherwise, find the size of the fish population in Pontu and the value of t when the rate of growth of the population. Okay. dt squared is equal to 0. So that's going to be the maximum of the rate of growth. So this implies that t, well, let's start with q, is equal to, so we need to solve this equals to 0. We need to solve this for big Q, solve, and we get 3 of these values. It's not going to be Q because 0, because that's when they release the fish, so obviously the biggest growth isn't going to be there. Q equals 1000 is undefined, so it's going to be Q equals 500. And so when does Q equal to 500? Well, we can solve this equation for x, and we get approximately 2 years. Tricky. All right. Now we sketch the graph of Q versus T on the set axes below. So I'm going to replace Q with Y so that the calculator can comprehend, and I'm going to graph it, and then I'm going to use the little domains that they're specified from 0 to 6. I'm just giving a little buffer so that and zoom auto to get all the values in the picture, and resize, and there we go, and then auto. Okay, so now that we've got everything in the picture, I didn't mean to do that. So what's that point looking like up there? Well, that's looking like 1,000. So let's do that once more. So I'm saying that there's an asymptote at q equals 1,000. Which we can draw. And then you could find that out by doing the limit as t approaches infinity, and you'd find that it equals 1,000, and so therefore there's an asymptote. And then what we found just before was that when t is equal to 2, we have a point here at 500. I think. Maybe. Probably not. Don't trust me on that. Yes, we do. Do trust me on that. And then we also have a point here, which is where we start off at. So let's draw that in. That's not very good. Let's try again. It's also not very good. It's also not very good. It's good enough. And it wants us to label the axial intercepts. And so that's going to be at t equals 0. We are going to have 100 fish. And that's when the farmer releases 100 fish. Nice. Okay. Let's go back to main. The farmer wishes to take 5.5% of the pot there. So we need to find the maximum number of fish. So the maximum is going to occur at dq dt equals 0, which implies that q is equal to, let's find out. Oops, we did not want that. We want 11 on 10 q, 1 minus q on 1,000, minus 0.05. Q is equal to 0, and we want to solve for q. Why aren't you graphing or solving? Are you too complex? Alright, I don't know why you're not doing that. So that's on 10x minus 11 on 10x squared, 1,000 minus 0.055x. Do you want to do that now? Do you want to solve? Will you be cooperative? Yes, it will. Okay. I don't know why I wasn't solving that. So Q is equal to 950. Oh, we're done with that. That's beautiful. We're probably taking really long here. We're at 35 minutes. And soon we'll be on to the multiple choice. Don't worry. The points with coordinates A, B, C all lie on a plane phi, or capital P, pi, capital pi, or I don't know Greek letters. Find the vectors AB and AC. So AB is just going to be 1 to 1. So 0, 1 to 2. That's a step of 1. So we're just going to have J. And then 2 to 3 is also a step of 1. So we're just going to have K. And then A to C is equal to, so that's 2 steps right there. 1 step right there. And 2 steps right there. Okay, so the area of the triangle, so we know that the area of the parallelogram is going to be AB cross AC. And so the triangle, if you think about it, that was terrible. I'm so sorry. The triangle is just going to be half that area. See, this is the triangle. So that's going to be 1/2 the magnitude of AB cross AC. So what is AB cross AC? Let's find out, shall we? So we want to go into our column vectors. Let's just do a simple template here. So AB is 0, 1, 1, and AC is 2, 1, 2. And we want to do their cross product, which is there. And so we get I squiggle plus 2j squiggle minus 2k squiggle. We all squiggle for I squiggle. And so that's going to be 1/2. Well, 1 squared plus 2 squared plus 2 squared is 9, which is equal to 3 on 2 units squared. And as we can see, that's what they wanted. So we need to find the shortest distance from point B to the line segment AC. So if we think this is A, and we think this is C, and we think this is B, let's use orange, because it's not auto-straightening. There we go. Then we want to find this point here. Let's do it in red now. This point E, because that's going to be the closest distance. So we know that we want to find the length of E to B here, and so that's going to be A to B minus A to E. And what's A to E? Well, that's just the projection of A to B onto A to C. So so the unit vector of A to C is equal to 1/3 of I squiggle. That's I hat. Sorry, I squiggle. Sorry, no. 2I squiggle plus J squiggle plus 2K squiggle. And so A to E is the vector projection. So you can use whatever notation you like. Hat times AC hat. Alright, so let's find out what that is. So A to B is this right here. And A to C is this right here, but we're timesing everything by 1/3, so let's do that. There's going to be a comma in between, and we need to do their dot product. That's 1. Okay, so it's just going to equal this. And so, which is just equal to A to C hat. Okay, so this is not a lot of working airspace. We need to now find the magnitude of E to B, which is going to be the magnitude of A to B minus A to C hat, which is equal to, okay, let's calculate that. So A to B minus A to C hat is this, and so now we do the normal, which is 1. So 1 unit. And I'm just going to signify that that's the distance. That's my answer. Not a lot of working out space. That's just a shame. I'm sorry, guys. It probably won't make sense with 3 lines of working out. A second plane, I don't even know what that letter is, has a Cartesian equation. So n squiggle is equal to 2i squiggle minus 2j squiggle minus k squiggle. And then this thing here, let's just call that L squiggle, is equal to I squiggle minus 2j squiggle plus 2k squiggle. So we need to find the angle between these, and so let's employ this little formula that we all memorize from birth. And so, okay, now we need to find the dot product. All right, so let's whip out the column vectors again. And so we get 2, -2, -1, comma, that's a full stop, comma, 1, -2, 2. My goodness, this exam is giving me a headache. And we do the dot product. Okay, so the numerator is 4. And so what's the magnitude of the normal? Well, that's just going to be 9. So square root of 9 is 3. And this is also going to be 9. Square root of 9 is 3. So 3 times 3 is 9. And so that's going to give us, in degrees, so let's change to degrees, the cosine of, let's just say x in this instance, is 4 divided by 9. We need to specify that we're looking specifically from 0 to 90 degrees, and we need to solve that and change the decimal. So we get 63.6122, but we are not over. It's asking for the acute angle, so we need to do 90 degrees minus theta, which is approximately, so let's do 90 minus this, and we get 26 degrees in 1 degree. A line L passes through the origin, so its originating vector is going to be 0i plus 0j plus 0k, so it's just going to leave it like that. And then it intersects, and it's normal to the plane, so its directional vector is going to be the normal, so it's going to be 2t I squiggle minus 2t j squiggle minus t k squiggle, which is nice. Let's make that dot look bigger. Find the shortest distance from the origin. So the distance is equal to the absolute value of k on the magnitude of n. K is -18, and the magnitude of n is 3, so that's going to be 6 units. That's just a formula you should have in your resource book, probably. So find the coordinates of point D. So the D is the intersection point between the two vectors of the line and the plane. And so we need to find it between the line and the plane, which is 4. So it's 2 times 2t minus 2 times -2t minus -t is equal to -18. So that gives us 9t is equal to -18, which implies that t is equal to -2. And then if we find out what L is equal to at -2, we get -4. We get -4i squiggle plus 4j squiggle plus 2k squiggle. So therefore, D is equal to -442. That's our answer. Excuse me. Last question, I think. This is also a question that has an error on it, so we're going to skip a question as well, which is exciting. Okay, so a forest ranger wishes to investigate the massive adult male koalas in a Victorian forest. A random sample of 20 has a sample mean of 11.39. Okay, so let's clear all of this junk, get it off my screen. Okay, so a confidence is, the lower bound is going to be minus 1.96 times by the standard deviation 1 over the square root of n, which is 20. And then we can just employ the same thing, but a plus over there. And then we get So the confidence interval is, so that's just a formula. We just applied a formula. 9.5 and 11.83. 60 such random samples are taken and their confidence intervals are calculated. In how many of these confidence intervals would the actual mean mass of all adult male koalas in the forest? So we know that the mean mass in a confidence interval is going to be approximately 95% of the time, the actual mean mass. So that in 60 random samples. So we're doing 60 random samples. And so we need to do 95% of 60, which is 0.95 times 60. If you just left your answer as 95%, it would be wrong. So that's 57 samples. The ranger wants to decrease the width of the 95% confidence interval by 60% to get a better estimate of the population mean. So decreasing something by 60%, so 1 times 60, decreasing something by 60% is doing 1 minus 0.6 times 1, which is equal to 0.4. So you're in essence timesing something by 0.4. So we need to times by the width of the interval, which is given by this thing here, and that's going to equal something on square root n. And so that would give us 0.4, 1.96 times by 1 on square root 20 is equal to, copy this, x. And we want to solve for x. X I'm just replacing, n I'm just replacing with x. So that's at least 125 koalas. It is thought that the mean mass of adult male koalas in the forest is 12 kilograms. Okay, so the null hypothesis is going to be 12. Sorry, I've written that wrong. Mu is equal to 12. And then they think that it's less than this, and they're doing a one-tailed test. So that mu is less than 12. Okay, now we need to find the p-value. Okay, so the p-value is given by, since we're doing a one-tailed test, it's just, there's no 2 times out in the front. So x bar is less than, what did they say it was found to be? 11.6. Given that the mu is equal to 12, that stays the same, and the standard deviation is how many koalas? 40 koalas. Okay, so 1 on square root 40. And so this is approximately going to be, so we want to go interactive, continuous, normal PDF. Whip out the keyboard again, I don't know why I closed it. It's negative infinity to 11.6, 1 divided by square root 40 and 12. And that gives us a p-value of 0.0057 to 4 decimal places. And so as the p is less than 0.01, since we're doing this at a 1% level of significance, there is enough, there is sufficient, these are the words you've got to have to say, or else you won't get the mark. There is sufficient evidence to conclude that the mean mass, very angry mass, insulting mass, has changed. Nice. What is the critical sample mean? Okay, so the critical sample mean is given by x bar is less than c. All the bells and whistles stay the same. So mu is equal to 12, 1 on square root 40. And then so it's got to be greater than 0.01 for it not to be rejected. And so that means what we can do is inverse normal CDF 0.01. The standard deviation is 1 on square root 40. And the mean is 12, which gives us a critical sample mean of 11.632. What is the probability of making a type 2 error? So a type 2 error is accepting a false null hypothesis. So what's the probability that x bar is greater than? Because if it's greater than this, then we're going to accept it. Because this is the smallest sample mean for it not to be rejected, for it to be accepted. So if it's greater than this, it will be accepted with a mu equal to 11.4, and then standard deviation is the same. And so let's find that. I'm going to use this unsimplified value, though I don't think it will matter. I don't think it will change anything. So the standard deviation is 1 divided by square root 40, and the mean is going to be 11.4. So that gives us 0.071. And alas, here we come. This has got to be satisfying. Well, first let's explain why. Here on the diagram, they've mislabeled the null hypothesis and the alternative hypothesis. Here you have the null hypothesis, which is approximately mu is equal to 11.4. And here you have the alternative hypothesis, which is mu is equal to 12. But if you look back here, the alternative hypothesis was actually centered at mean with 12. So this should be H0, and this should be H1, meaning that with the current information right here, this question is impossible to complete. So we're not going to do it. I assume that everyone will receive that mark. Time for multiple choice. A couple of that stuff was pink, but we kind of gave up on that. It doesn't really matter. Time for multiple choice. We're 50 minutes in, which is nice. Okay, consider the following statement. We need to find the contrapositive. Oh, I've just brought myself all the way back down. That was stupid. Let's just clear all so we can get a fresh start. If my football team plays badly, then they are not trying enough. So it's going to be the opposite of this statement and the converse. So the opposite of these statements, and it's opposited. So it's going to be if my team is training enough, then they will not play badly. So it's not going to be this one. It's not going to be this one. It's not going to be this one. So if they are training enough, then my football team does not play badly. It looks like that one. But what's this one? If they are training enough, then my football team will most likely win. Well, the opposite of this statement isn't that they're most likely to win. The opposite is that they're not going to play badly. You can still play goodly and still lose. You know, that's the moral of the story. The graph of y equals blah, blah, blah has asymptotes given by that. Okay, so x equals 1. So it's going to have a asymptote at x equals 1. So that means that, let's whip out simultaneous equations here, because this is going to be a simultaneous equations question. B times x plus c is equal to 0, given that x equals 1. Okay, so that's our first little equation. And then what we're going to need to do here is we're going to have to do a partial fractions decomposition on this. So if we do that and do a partial fractions decomposition with respect to x, we get this. So we get all of this stuff, which we don't really care about. We care about the linear term here. And that linear term we know is going to equal to 2x plus 1. So ax minus b on a squared is equal to 2x plus 1. If we break that up into the components of the gradient and the y-intercept, we get 1 on ax is equal to 2x, and which is going to imply that a is equal to 1/2, so it's going to whip out these options. And then we're also going to get that negative b on a squared is equal to 1. So that's going to give us negative 4b is equal to 1, which implies that b is equal to negative 1/4. So it's going to wipe out this option. And then now that we have the previous condition, which was that we can rewrite this, we get 1/2 minus 1/4 plus c is equal to 0. And we can solve this for c. And we get c is equal to negative 1/4, which is this one. In the interval negative pi, x pi, the graph of y equals... Okay, so what we're going to do is we're going to use the little variable grapher. So let's initialize this. So we get a plus secant of x. So secant of x is 1 over cosine of x. And so we get that, and we draw everything here. Oh, we're still in degrees. I apologize. Make sure you're in radians. That looks much more friendly. Oops. And so we want to look at this from negative pi to pi. And we want to see how many roots it has, how many x-intercepts it has. So let's go through the first equation. So we're at a equals 0 here. We're at a equals negative 1, sorry. So at a equals negative 1, we only have one root there. So we know it can't be this one because that's inclusive. Oh, sorry. We can't be this one because that's inclusive of negative 1. It also can't be this one because that's inclusive of negative 1. Alright, so let's have a look at 0. How many roots does this have at a equals 0? It has no roots, so it can't be a because that's inclusive of 0. So in order to disprove b, let's have a look here. So at negative 3, it has 2 roots, meaning that's not in this interval, meaning that the only acceptable answer is e. So let's check a equals 1, and that has 2 roots. It has 1 there, it has 1 there, so e is our answer. Happy days. Okay. Question 4 is a complex question, so let's switch to complex. So in my opinion, it's just going to be easiest if we just type this out. So 4a over 1 plus, so the conjugate. So we can do that. If you don't understand what the conjugate has an effect on, we can just do that here, and we get this answer, which is nice. And we need to convert that to polar form because it looks like everything is in polar form. So we get root 2 cis of 3 pi and 4. Nice. Let z be a complex number where real of z is greater than 0. All right, so let's draw a little argand diagram here. So real of z is greater than 0 and imaginary z is greater than 0. So that leaves this little region is for what z could be in. So it's conjugate. So let's just call z somewhere up here, which means that its conjugate is going to be down there. Its magnitude of its conjugate is going to have 4, which also means that this is going to be 4. And the argument of z cubed is equal to negative pi. So that means the argument of z is equal to negative pi on 3 or pi on 3. I reckon it's going to be pi on 3 because if it was negative pi on 3, it wouldn't be in this conjugate. So argument in this what's it called? Segment, no, quarter? I can't remember. It was one of these 4. Quadrant. Yes, that's the answer. So pi on 3 is going to be there. And so z cubed is going to be negative pi, which is going to be there. So z cubed is going to be there. Z squared is then going to be all the way over here. So z squared. And so z squared is going to have a magnitude of 16. So let's have a look at these options. So 4 times z is just going to end us up over there. So that's not our answer. Negative 2 times the conjugate of z is going to get us to a magnitude of 8. So it's not going to be that. 3z is going to not get us to 16. The magnitude squared is going to get us to 16, but if we square that, we are just heading over there. So that leaves our only answer over here. So let's check it. Negative 4 is going to reflect. It's going to reflect us like this all the way up here, and it's also going to do a times of 4, so that's going to get us over there. It's a bit confusing with the diagram, I'm sorry. All right, so consider the following pseudocode. All right, so let's just do something. Define f of x comma y equals to e to the x times y. And so let's define that for us. Okay, so for our first iteration, we want to find out what, okay, so it's 0 plus 0.5 times f of 0 and 0. So that's going to give us half. So we got a half, 1. And so that's our first iteration. So y is equal to a half now. So a half plus 0.5 times f of 1 half and 1 half is going to get us this. So let's approximate. In fact, let's just change to decimal mode. And so that's our second iteration. So let's plug that in there. And then so our x is going to become 1 now. And our y is over there. So on our second one, we got, and so on our third one, we get a y is equal to 2.709, which is this, which is our third one. So that's C. The direction field for a differential equation is shown above. On a certain solution curve of this differential equation, y equals 2 when x equals -1. So y equals 2. So it goes there. The value of y on the same solution curve when x equals 1.5 is closest to. So let's follow the lines here. This is like the funnest thing in Spesh. And so we get there, which is 1.5, which is 1. So our answer is 1. Nice. Initially, a spark pool is filled. So I was looking at this question. I didn't know how to do it, which is a bit sad. I tried looking at some other bloke's solution of it, and he assumed that the spar initially has a quantity equal to 0, but that to me just cannot be true because it contains a quantity of dissolved chemical, and they've already said that it's too much chemical. So I don't know how to complete it. I'm sorry, guys. You guys, you can do it. You guys are smart. But I'm going to skip it. And so the position of a particle moving in the Cartesian plane at time t is given by the parametric equations x of t. Okay, so we need to find some relation or equation. So the first thing to do is to get x, to get t in terms of x, so we can substitute it into y. So let's just write this equation out. We've already screwed something up. Unambiguously, 6t, t plus 1. And let's solve this for t. And we get t is equal to -x on x minus 6. And so if we substitute that in, y is equal to -8 on t squared plus 4. Given that t is this, we get this equation. Okay, so when t is equal to 2, what is x equal to? Well, t is equal to 2, and let's get rid of the solve. Oh no, we'll just put it over there, stupid idiot. X equals 4. Okay, so let's derive this to get the gradient of the tangent, and we know it's going to be at x equals 4. We're in decimals, so let's try again. 3 on 4, which is our answer over there. Okay, if I sub n, okay, so let's work this out. This is weird. I can't believe they put this on the exam. So we need integration by parts here. And so this is just going to be I sub n is going to be equal to, so let's do something. That's done. Let u equal to 1 minus x to the power of n. Dv dx is equal to e to the x. V is equal to e to the x. And then so du dx is going to be equal to, employing the chain rule, we get a negative outside the front because the negative here. N 1 minus x, and then n minus 1. So we get I sub n is equal to e to the x 1 minus x to the power of n minus the integral from 0 to 1, and this is also 0 to 1, of negative n 1 minus x to the power of n minus 1 dx. If you evaluate this at 1, we get 1 minus 1, 0, so everything becomes 0, and so we minus it evaluated at
0 is just going to be -1. And then we can pull out the minus here. So we get plus n, the integral from 0 to 1 of 1 minus x to the power of n minus 1. Sorry, this should also have an e to the x in front of it. E to the x dx, which is equal to -1 plus I sub n minus 1, which is u, which is nice. The area of the curved surface generated by a revolving part of the curve of the equation y equals cosine inverse of x from 0 to pi 2 to 1, 0. About the y-axis can be found by evaluating. Okay. So, since we're doing it about the y-axis, we want things in terms of y. So x is equal to cosine of y, which means that dx dy is equal to negative sine of y. So our surface area is equal to 2 pi times the integral from 0 to 1. I think, yeah, 0. Oh, but we're doing stuff in y, so it's 0 to pi on 2. And this is going to have cosine of y at the front. And we're going to have times by 1 plus sine squared of y dy. Let's let u equal to sine of y, which means that du dy is equal to cosine of y. So the surface area is equal to 2 pi, the integral from, okay, so when y is equal to 0, u is equal to 0, and was y equal to pi to 1, and then we get 1 plus u squared du, which looks like u, mi amor. Alright, the acceleration of, okay, so let's whip out the formula sheet. Let's get the acceleration formulas that no one remembers. So I reckon acceleration is equal to dv dt, which is equal to 1 plus v. So dt dv is equal to 1 on 1 plus v, which means that t is equal to ln of 1 plus v plus c. It says at rest, so at t equals 0, v is equal to 0, which means that ln of 1 e to the power e to the power of what is equal to 1 is 0, so you get c is equal to 0. And so now at ln of e plus 1 is equal to ln of 1 plus v, which is that e plus 1 is equal to 1 plus v, which means that e is equal to v. So we get A. Tough. A tourist on a hot air balloon. Wow. Is rising vertically at 2.5 meters per second. And accidentally drops a phone. Oh no! Which is above 80 meters. So this is 80 meters high. And so it's going to go down at an acceleration of 9.8 meters per second squared, because I think that's the thing that they ask us to use. G, yeah, 9.8. Okay, so if we look at our kinematic formulas, S, which is 80 meters, is equal to our initial velocity, which is negative 2.5 t, plus 1/2. Our acceleration is 9.8 t squared. And if we solve this for t, 2.5t plus 0.5 times 9.8 t squared, solve that for t, get two answers. T is approximately 4.30, which is E. And it should work if we do it the other way around as well. So 80 is equal to 2.5 minus 0.5 times 9.8 t squared. Oh, no, it doesn't, because that's no solution. Yeah, it's fine. Yeah, it works this way because we're doing it in the frame of reference that gravity's going downwards, so it's fine. Let's get that bollocks off my screen. A squiggle is equal to I squiggle plus J squiggle, B squiggle is equal to I squiggle minus J squiggle, and C squiggle is all that. Okay, so if n is a unit vector such that A dot n is equal to 0 and B dot n is equal to 0, so A and B are both perpendicular to n, which means that it's given by the cross product of A and B. So A is U, and B is U, so it's given by the cross product of these terms, which is negative 2k, and so that and C dot n 1 2 3 1 2 3 4 and cross no, not cross product, dot product, we get negative 6, and so the magnitude of negative 6 is 6. If the sum of two unit vectors, okay, so we've got a unit vector over here and unit vector over here, so they both have length 1, and so the sum of them is another unit vector. Okay, which means that this is an equilateral triangle. Which means that they all have the same angle, which means they all have the angle pi on 3, pi on 3, pi on 3. Then the magnitude of the difference of the two vectors. Okay, so the difference is going to be this, which also has that. And so the difference of them is going to be that. And so this is unit vector, this is unit vector, but we don't know what that is. We want to find what that is. We know that this is going to be an isosceles triangle. This is pi on 3, which makes this 2 pi on 3, which makes this pi on 6, makes this pi on 6. We can do the cosine law. So let's actually call this a squared. So a squared is equal to b squared plus c squared plus 2bc cosine of A. A is going to be that angle over there. B squared is 1, c squared is 1, 2 cosine of 2 pi on 3. Sorry, that's minus. That's my apologies. Oh, always make a mistake. 1 plus 1 minus 2 times the cosine of 2 pi on 3 gets us 3. So A is equal to square root 3, which is D. A student throws his ball for the dog to retrieve. The position vector of the ball related to, okay, displacement components, yep. The total verticals. So the only thing we care about is this. So since that's the only thing we care about, I'm going to replace the t's with x's and just graph it to have a look at the way that the vertical distance is changing. So we can see that we start here at, so when t is equal to 0, so when x is equal to 0, we start at 3 on 2. So we start there, and then we go up all the way to the turning point. Oops, oopsie daisies. The turning point, which is 12.9, but we also need a minus off. Minus off the 3 on 2. And then we go down another 12.97959. And so if we work that out, we get 97959 minus 1.5 plus 12.97. We get 24.45, which is 24.5. Nice. Consider the vectors alpha I. So if A cross B is equal to C, Okay, so let's work this. So A is, let's call that A1, -1, across 3B4. And let's do the cross product. And now we need to do simultaneous equations of B plus 4 is equal to 2. -7 is equal to -7. That's cute. And B minus 3 is equal to, let's call that X. So let's solve for X and B. So we get, so this little, I think it's called gamma. Gamma is equal to -5, which wipes out this, this, this. And beta is equal to -2. So that's our answer without even looking, which is nice. Nice. Cool, clear all out that. For what value of k will make the following planes perpendicular? Okay, so that means their normal vectors are going to be perpendicular. So the dot product of their normals is going to equal 0. So -k3, comma, 2k, so that's an L, 2k3 minus 2 is equal to 0. And so we do, oh, let's do the 0 part later on. So the dot product, so k minus 6 is equal to 0, which means that k is equal to 6. Nice. Last two questions of the exam with 45 minutes to go, but keep in mind that we skipped 2 questions. One because there was an error and one because I'm a dumbo. A company accountant knows that the amount owed on any individual unpaid invoice is normally distributed with a mean of $800 and a standard deviation. What's the problem? That the total amount, okay, so the total amount is going to be 800 times by 16, and it's going to be root 16, so that's 4 times by 200. Okay, so distribution continuous, normal CDF. So the lower is 13,500, the upper is infinity. Standard deviation is 4, so root 16 times by 200, and our mu is 800 times by 16. And so that should give us 0.191. The lifespan of a certain electronic component is normally distributed with a mean of mu hours and standard deviation of omega hours. Given that 99% confidence interval based on a random sample. Okay, so n is equal to 100. Okay. So the mean is going to be the average between the upper and the lower bound of the confidence interval, which is 13,000. Okay. And so it's wanting a 99% confidence interval. So if we do the inverse normal CDF of 100 plus 99 divided by 200, I think it's 200. I'm not sure. Yeah, it's 200. If it was 100, that would be an error. Okay, so divided by 200, so that's our k value. So we know that 13,000 minus this k value times by the standard deviation, which we'll call x, over the square root of 100 is equal to 10,500. So let's solve that for x, and we get 9,705, which looks really close to A. And so those are my answers for this exam, barring one, technically, because one has an error. Overall, it was a weird exam. Multiple choice was particularly hard, like particularly hard. Some of these questions have traps. A lot of them are 1 or 2 mark questions, particularly heavier on the 1 mark questions, meaning that if you make a tiny error, even if you understand the conceptual elements, which is what these exams should be testing you on, you will not get the mark because you made a tiny error. Like if you didn't include the first disk here, you'd only get 1 mark. and 1 mark here, in my opinion. A lot of these marks, if you make a tiny error, you would not get 1 mark. 1 mark. There's loads. 1 mark, 1 mark, 1 mark, 1 mark, 1 mark, 1 mark, 1 mark. In fact, this whole question about the probability is 9 marks, consisted of 9 questions. 1 mark per question, which is ridiculous. Anyways, those are my solutions. Peace in the Middle East.